All right, everyone, welcome. Connections are connected, they're downloaded, and stuff like that. And thank you for sticking with us. Anyway, my name is Eric Wall, and I am the current chair of AIAA San Francisco section. And we are very happy to have you all here with us tonight. We love putting on these presentations for all of you. And of course, we can't do that without the support of our membership. So for any of you who are members, thank you for that. Much appreciated. And for anyone who isn't, if you might be interested, please feel free to come and see me, or we have a couple other council members here as well after the presentation. Anyway, since we're running a little bit late, I'll cut my usual spiel a little bit short, and let's jump right into the introductions. Sina, take it away.
Hi everyone. Tadros is the CTF at Redwire, focusing on strategic investments, technology development, and a collaborative technical culture. With nearly 30 years in aerospace, he's a leading expert in space servicing and manufacturing. Previously served as Chief Growth Officer and Executive Vice President of Space Infrastructure at Redwire, driving growth and mission capabilities. In this position, he was responsible for advancing development, increasing adoption, and building momentum for Redwire's mission-enabling capabilities within the civil, defense, and commercial space sectors. Before that, he was Executive Vice President of the Space Infrastructure and Civil Space at Maxar, leading innovations in spacecraft design and space infrastructure, and integrating robotics and space satellite manufacturing, servicing, and assembly capabilities. Please welcome Tadros.
Thank you, Eric, for hosting this event, and thank you all for being here. As Sina mentioned, I've been in the industry for about 30 years, but I felt intimidated when I met Ed here for only 50 years in the industry, and then Krishna for another 50. So combined, they exceed the space of the whole space history. So I'm going to try to talk a little bit about things that are maybe things you don't hear about very much. People talk about rockets and constellations, communication, Earth imaging. I'm going to not try to talk about that, but a little bit about what's going on in the space industry in the bigger sense, what we're doing at Redwire, and some really unique missions that are going on. I hope to talk about 30 minutes or so, and then have 30 minutes of Q&A, or as long as you'd like. I can talk more on any topic. You can just ask me, can you tell me more about XYZ? And I will ask you a question at the end if you heard about something here that you had never heard was being done in space before. So that's the question I'm going to ask you. So think about that as I go along. The first thing I'm going to show you is a short video. I think most of you probably know that the whole human experience, at least our human experience, is dependent on our space systems. We do not have most of what we are, take for granted without space systems like the GPS constellation, communication satellites, weather satellites, even climate measuring satellites that are basis for a lot of the knowledge we have of the Earth. The whole human experience is kind of dependent on space, and a day without space is a day that sets us back 100, 200 years. So with that in mind, I'm going to play a short video here for you from a vision of what Redwire sees the space industry is. Might need your help. Oh, okay.
Beyond Earth's atmosphere, there's an advanced network of space technology. Certainly, it's the one watchtowers would take our name and shoot safe and dark-lived lives. That makes our global skewed roads. So does our visions, urgency, yeah. So, and Redwire, we are honored to support those stars who defend our nation. and experience to operate in space. Together, microgravity deploys solutions for warfighter communications that speed the exchange of information and shorten decision-making chains. Building resilient mission architectures to mitigate threats and ensure dominance throughout space. With our capabilities for space domain awareness, we help ensure the safety, security, and sustainability of our nation's activities in an increasingly contested environment. In the face of the unknown, we stand ready to serve the brave men and women, act as our guardians, and using cutting-edge technology for protecting our future. Together, we can defend above.
And maybe especially during Memorial Day week here, this is appropriate video. But not that the talk is all about military and military applications. However, one of the unique aspects over the last 4 or 5 years is the discussion of war in space. That wasn't really a front page public discussion before, and now you hear much more about it. In fact, the Wall Street Journal just had an article about, I think it was in the title, War in Space, and had a number of the Pentagon officials talking about it. So the reality is, where there is advantage, national advantage, there will be military activity, and that's our reality. The images I'm showing here are of satellites. These are satellites that we're fortunate at Redwire to be working on, but probably satellites that you aren't very familiar with the domains of. On the left are satellites for VLEO, very low Earth orbit, talking about things below 300 kilometers down to 150 kilometer type of range. This is the edge of the atmosphere, and in fact, it's not quite atmosphere. It is actually the plasma that bounces around on top of our atmosphere. So this is not continuous flow. This is not an air as we feel it. This is ionized atomic oxygen, nitrogen, and other molecules. Flying through this, you do have drag, but you also have the opportunity of using those molecules, collecting them, and using them in an electric propulsion system. So that's something that we're working on right now. If you can collect these molecules at a rate efficiently enough that you can contain them, and then use them in electric propulsion, of course, spewing them out 1,000 times faster than you collect them, then you can actually compensate for drag, and you can persist at that altitude, because the energy you're bringing in is through electric solar panels or solar electric energy. So these are 2 missions that we're building. One is called SaberSat, and one is called Phantom. As you can tell from the flags, one is actually a US developed vehicle, and the other one is being developed in our Belgian office for the European Space Agency. There's a lot of interest in this. One of the reasons is that our adversaries are starting to move into this regime, and there's a lot of advantage in being in this regime. For an engineer and a technologist, it's exciting that after 30 years of working in the industry, there's a new domain that I haven't worked in that we're starting to explore. On the right side is a mission we're building in our European office called Proba 3. This is a combination of 2 satellites, formation flying, and conducting a solar science experiment. One is carrying a solar coronagraph, measuring the outer rim of the sun. The other one is actually an occulter. So it's a disk that blocks the sun's light, so that the coronagraph can do the science. Now there's various versions of these. I'm sure you've all seen star shades and others to look at exoplanets directly by telescopes. This is intended, again, for flying in Earth orbit to view the sun, and this requires a formation flying of about 100-meter separation with a few millimeters of accuracy. So a technology that hasn't quite been rung out yet, but is critical to achieve the science that we're shooting for. And as was seen just a few days ago, the sun is a very dynamic beast. It can sometimes behave in ways that concern us with regards to our dependence on space systems, on terrestrial systems, and so forth. So the importance of that science was only amplified by that. On this note, more and more science research is going into operating swarms of satellites. So there's quite a bit in small satellite development. Operating swarms of satellites is complex for a few reasons, but has the advantage of potentially giving you mission capabilities that you can't get from an individual small satellite, or even a constructed large satellite. So swarms of satellites could be hundreds of meters separated, kilometers over kilometers, and conducting a mission. If you're interested in hearing more about this or similar, there's a mission called Starling, Ling, not Starlink. Starling is a mission that NASA Ames and a few others, Stanford and a few others collaborated on, was launched earlier this year, and has been bringing back great data and performance from that mission. Again, these are capabilities that are recently being developed and deployed. I'm sure you've all heard about Artemis. If you haven't, there's plenty online to read about, but the capabilities and the technologies that go into sustained human presence or persistent human presence are substantial. Everybody sees the rockets and the human landing systems. I get it, that's all cool. But persisting on the lunar surface has a lot of challenges. One of the things that Redwire has been investing in and has a contract actually with NASA to do is how do you build infrastructure out of lunar regolith? And particularly, how do you build landing pad? So those pictures of, in this case, Starship or any rocket of this size landing on the moon on a flat surface really isn't possible. Unless you have built a landing pad that can resist the blast from the rocket. So we, on the left side of the view here, we've been developing a capability called Mason. It's using RF sintering of lunar regolith to build basically solid structures, concrete-like structures on the lunar surface. Sintering is basically melting it together. So heating it up to the level where it melts and solidifies together. So that is one technique that's being deployed in order to build landing pads, roads, thermal shields, as well as radiation shields and micrometeorite shields. The moon is a very unforgiving surface for a lot of reasons, the temperature range that it goes through, as well as the exposure to space without atmosphere. So it gets the direct, solar radiation, it gets the direct micrometeorite impacts, hence the way it looks with craters. It is a tough place to persist. So some of these technologies are critical for us to keep astronauts there for long durations of time. There are people working on lunar terrain vehicles, and you probably heard the 3 contracts that were issued on lunar terrain surface for both transporting astronauts, but also robotically transferring equipment autonomously. So those are some of the infrastructure that's being now deployed and operated as a service on the lunar surface by others. And then one other thing I want to just point out are the solar arrays there on the right side. So Redwire is fortunate to be the supplier of the rollout solar array for the space station. If you've got a chance to see it, it's pretty spectacular. It's pretty spectacular for a few reasons. For an engineer, it's rare that you see equipment deploying while an astronaut is next to it. So when you take a look at that video, and you notice that the astronaut is at the bottom and looks like this, solar array is about this big and deploying out, you get a sense of the magnitude of the solar array. But that's the trust that you have to be able to build for human spaceflight systems, is to be able to deploy in the midst of an astronaut. In this application, we're modifying the rollout solar array to deploy vertically in 1/6 gravity. So in vacuum of space and in microgravity of orbiting space, you don't need to fight against gravity. On the lunar surface, you don't get zero gravity, which is good, it helps mobility to have some gravity. You have to deal with 1/6 gravity. The other thing you have to deal with is lunar regolith, which is persistently attracted to a lot of stuff. Electrostatic attraction to the surface of materials, solar arrays, and others is one of the issues. And the Apollo astronauts, found that it, was on their suits when they went back into the capsules. And then there's a concern about the health hazards that it poses and so forth. It also has challenges with mechanical devices. Again, some of the challenges that we're up against if we're going to persist and operate on the lunar surface, which is great for engineers, lots of problems to solve, but it is hurdles that we're going to be up against in operating. The Mason program, if you're interested in hearing more about that, we're passionate about it. We just are at PDR now and going towards CDR with that capability. So I think everybody's heard that there's a lot of things in space, thanks to more access to space, more frequent access to space, which is a good thing, but that gives you the opportunity to launch a lot of stuff in space. Falcon 9 alone launched close to 100 times last year. Almost half of those were just for their Starlink constellation. This year, they're estimating about 150 launches a year. About every 2-3 months, they have a transporter mission that they're launching. These transporter missions compile a lot of small sats together on the order of 50 to 100 small sats in any one launch. This is a lot of access to space compared to historical, and where we actually, if anybody's attended small sat conference, would have to go overseas to find ride shares or access to space. So the good and the bad of that is that we have a lot more startups who are, basing their business on satellites, small satellites, and a lot of missions being tried out, a lot of new instruments being tried out. The bad is that, there's a lot of things being put up that can afford to go up that might not be able to both sustain its operation and deorbit at the end of its life. So we end up with, orbital debris that we have to manage through. So that's one of the challenges that we as an industry are dealing with. The minimum, the challenge is to understand what is orbital debris and what is friendly commercial activity, and then what are our adversaries' nefarious activities. And that isn't always clear or obvious, especially when you have zero visibility. So space situational awareness is becoming a bigger and bigger topic, not only where something is, just knowing where things are, but also what their intentions are, what their capabilities are. That kind of information is part of what space situational awareness is heading to, and we're developing cameras that both have the optics to be able to view objects, but then the compute power to identify and characterize the objects that it's viewing. This is important in long range for space situational awareness, and then at closer ranges, we're doing rendezvous and proximity operation. That's another topic that wasn't really talked about a lot before, and now is in many startups' repertoire is rendezvous and proximity operations. Approaching other satellites was not really encouraged or even allowed in many cases before. Now, with formation flying, with rendezvous proximity operations, docking, there's a lot of business cases that are and missions being wrapped around that. So I mentioned cameras. Around here in Silicon Valley, you're seeing a lot of self-driving vehicles, both cars as well as drones and others. There's a lot of discussion about sensors and autonomy in vehicles. We're deploying cameras on a number of vehicles, including the Orion capsule, which flew Artemis 1. Those were our cameras that did the selfies of the Orion capsule with the moon and Earth in the background. But those cameras are also able to compute things like navigation with sun, earth, and moon, identifying location and navigation parameters for vehicles. They're also able to characterize the position and orientation or pose for a vehicle that you're approaching if you're looking to dock, so forth. So applications from SSA to robotics to autonomy inside habitat are all part of what we're looking at doing with cameras and sensors in space. We've had cameras also. Another version of RPO, I guess, is lunar landers. So there's a lot of small CLIPS landers, commercial lunar service payload landers that are flying, and these cameras can be used for descent, obstacle avoidance, and autonomous landing. Another good thing about the blossoming of the space industry is the ability to collaborate. And there are a lot of universities and new companies, older companies that are out there, and we're able to collaborate and make the best, use the best of all. I'm showing here an activity that we're doing with Stanford University in artificial intelligence enabled autonomy for space vehicles. So a few professors in the aerospace department, Simone D'Amico and Marco Pavoni, started an initiative called Caesar, and the intent is to translate a lot of what we're doing and seeing here on terrestrial systems to space systems. And it's moving very fast. When it started about 18 months ago, there wasn't any ChatGPT or any of that out there. Now the popular media is seeing, or the kind of consumers and popular culture is seeing what AI is capable of doing. But really the technical kernel are things that are beyond the classical techniques for control, for navigation, for perception. Those are the things that we're advancing and working in with Stanford, and Blue Origin is also a sponsor of that research. Exciting activity. It also starts to introduce the next generation aerospace engineers to what we will need, right, in engineering and GNC and in attitude and orbital control systems going forward. Okay, another area that we are fortunate to work in that you might not be aware of and is part of the future space economy is microgravity research. We have 10 research racks on the space station that is doing taking advantage of the microgravity environment for the benefit of humanity here on Earth. So we have everything from additive manufacturing, ceramics, plastics, but also additive manufacturing in a bioprinting sense. So we have a bioprinter on the space station. Also crystal growth. So we have crystal growth for pharmaceutical industry that we're demonstrating and showing success in. Along the way, we're partnering with terrestrial industries that are already doing research in these areas, and then giving them the capacity to do the research in space by Redwire building the equipment that allows for that research in microgravity environment. So these are some of the payloads that are on the space station that we've deployed, and now with the cargo missions that are going up frequently to the space station, we're able to take up new cartridges, new experiments to run on these facilities and bring back the results and do that at a much faster tempo than ever before. As the space station ends its life in another 5-10 years, the expectation is that there will be commercial habitats that are also going to be deployed. And this is some of what they're going to be picking up. So we're working with the next generation habitats to lay out the requirements of what will they need to do for both the research, but then the industrialization, the production of some of this results. So just to give you a recent, very recent, in the past month, and we put this out in the press, we were able to 3D print human heart tissue. the reason you do it in microgravity, there is bioprinting here on Earth of human tissue. The reason you do it in microgravity is to get the 3D structure without any scaffolding or any structure, any materials internal that interfere with the growth of the tissue. So we conducted the experiment in microgravity, packaged it back up, brought it down in the cargo vehicle, the Dragon capsule, and that's what you're seeing here as the result of that on the left side. On the right side are crystals that are grown in space. Again, the same effect. Microgravity doesn't have buoyancy effects in fluids and doesn't have differentiation between up and down and left and right. So the types of crystals that can be produced are superior for the pharmaceutical industry, and that means the efficacy of the medication, side effects, and other things that can be controlled. So that's a whole exciting area that we're working in, and is part of our space industry. If you haven't heard about regulation and policy for space, it is thick out there. So you don't have to be an engineer to be in the space industry. There are a lot of poli-sci, lawyers, politicians that are amongst us. So Artemis Accords is an example of where we want to create a community that has a norms of behavior on the moon that they agree with us, with the U.S. in how to behave and operate in the moon, at the moon. So we want international collaboration at the moon, and we want to support that. Artemis Accords helps define, okay, what does that mean? What will we do if you find resources? How can you extract them, make benefit of them without disrupting other people? So that's an example of what's happening right now. There's a whole slew of things right now being discussed about not only the moon, but cislunar space operating in between the Earth and the moon, and then LEO. I find it encouraging that when I go to a university, space clubs that have members that are not only engineers or in the aerospace department, but are also from finance or legal or departments around the campus. So that's always encouraging for me to see. Okay, that's all I'm going to actually say here today. I can talk about any of those items a lot more as you're interested in. But first of all, I am curious from what I described here. Did anybody see or hear anything that they heard before about the space industry or about missions to space? Okay, all right, good. I'm glad that some of it was relatively new and hopefully piqued curiosity. All right, any questions? Or Eric, I don't know if there are any questions online.
I'll take one, but don't be shy. Go ahead.
Well, I'll ask a question. You mentioned, you brought up the thing I hadn't heard of was a successor to the space station, and that might be a commercial venture.
Yeah.
I'm kind of wondering,
Yeah.
what are the economics behind that? And I guess the bigger question is, do you think as the space economy grows, is it going to be government regulated or commercial, or what kind of thoughts there?
Yeah. So there are defined programs right now, commercial LEO destinations. NASA is seed funding multiple contractors to start deploying commercial habitats. There's one that's actually contracted to attach a habitat to the space station and then later potentially remove it. NASA is also wants to be one of the users of those. So they want to put astronauts on there. They want to continue to have astronauts in low Earth orbit. They want to do research there. So they want research racks and so forth, but they don't want to own it and operate it or fund all of it themselves. So that's why it's called it's commercial. What are the economics? Let me start by saying this. What we know about space and what we see about space station is defined by NASA's mission, which is research and exploration. That is not what most people experience in their daily lives. In fact, very few people experience research in their daily lives. But the real question is, what are the economics of a space station if a commercial company can open up, a resort in space or a gym in space or a bar in space? So those are the real questions, and that's what quite honestly people spend their money doing. It'll initially be a luxury item, right? And people pay $50 million, $100 million for a yacht. So there's people that will pay to have an experience that's very unique like that. Each of those companies are working on their business case and raising funds for that. So that's what you should expect to see. Some very interesting ideas out there. Yes.
Just the mass research rolled out.
Yeah.
Wondering when green mass 100 megawatt.
Yeah.
24/7 power supply.
Yeah.
Sort of it.
Yeah. So the rolled out solar array has the biggest advantage as you get to larger, higher power. The packing factor of rolling up versus folded solid panels is much better. I'm not going to throw out numbers directly, but the solar arrays for the space station, for example, 25 kilowatts a wing, and hundreds of kilograms type of mass. So if you have a grid of those on the lunar surface to get a megawatt power grid or something, that's very feasible in the context of the landing systems that are being funded right now. Blue Origin and the SpaceX landing systems, hundreds of kilograms is very feasible for them.
Is any of your planning taking into consideration and expected increase in payload capacity once big ships start flying?
Starships?
Okay.
Yeah, super heavy lift or whatever you call them. Yeah, that's actually one of my very keen interests is what does it mean to have 100 tons to LEO or 100 tons to the lunar surface? When for the past 30 years or 50 years, we've been trying to slim down mass on everything. Now, all of a sudden, somebody's going to tell us, yeah, for the same price, you can take that end of pickup truck to the moon. So I think that there's a few things in that. One is once you get it to the moon or wherever, you still have to move it around. So you still have to move it and locate it, position it. So there is some sensitivity there. The other is you still have to survive launch. So there's some balancing, but I do think that that's a very interesting question, and we're going to start seeing, what people meant by small sats was really low cost satellites, and if you can do low cost by just taking a terrestrial hardened kind of structure, that might be the cheapest way of doing it. So yeah, that'll be one interesting thing to watch. Yep.
You've mentioned there was an experiment at the ISS regarding 3D printed human heart tissues.
Yeah.
So I guess it's going to be two part. The first part is how much more trusted is the concept of 3D printing organs in space? And part two is what would be the difference between applying organs that were 3D printed in labs here on Earth and 3D printed organs printed in the ISS with some other station?
Yeah.
In regards to economic differences, costs, etc.
Yeah. Good questions. First of all, I am not a biologist or bioprinter expert, so I want to caveat that. The feasibility of doing this in space might be getting beyond things that you simply can't do on Earth. It might not be whether it's just more economical or not. There might be things that we're doing in space that just aren't feasible at any price on Earth. So that's one consideration. The other is that we are envisioning a future where up mass launch and return is much more frequent, possibly with a fully reusable launch vehicle like Starship or Stoke. I'll name some others so that people don't think it's just in that realm where you might be able to launch a whole platform robotically, not uncrewed, conduct the research or the production, and then return it, starts to get to the economies of what we're thinking about. It's not necessarily going to the space station and using astronauts to manufacture things at volume. So there are a few parameters that aren't in the think about it the way it's being done right now realm. If this is an area that you're very interested in, I'm more than happy to connect you, especially if you're doing research in this area, to connect you with our team that can tell you more about it. Yeah, we have a team that's been focused on this kind of research for 30 years, going back to before the space station on shuttle experiments. So this is not a recent interest of ours. Other question? I think you had, yeah.
So going off the 3D printing of the biotissue, I'm curious of how your researchers are programming 3D printers you guys are using.
Yeah.
And also, since you guys have a background in 3D printing, did that have an effect on the Mason project? And are you guys kind of translating a lot of those engineers from the 3D printers into that project?
Yeah. Good question. I'm trying to think of, so yeah, there is a lot of intermixing of concepts and understanding and experience. Of course, Mason has to operate in 1/6 gravity where they can set stuff down and leave it. That doesn't happen in the microgravity environment, and that's why we're in it. I don't know that there's been a whole lot of mixing, and there's also Mason is outside in a vacuum, and all this research is inside a habitat in one atmosphere, short sleeve kind of environment. So not necessarily Mason, but there has been, like I mentioned, a long history of additive manufacturing, 3D printing type of materials, and that has fed into the bioprinter research. And it can be simple things like maintaining the raw materials, right? Sustaining it at a temperature. How do you feed it without damaging it? Those kind of things. We've had a lot of experience working, with different materials, and this is just another material, but we allow it then after printing to actually grow, in space and form into a single full tissue. So I guess those are my quick comments on that. Yeah.
You mentioned this edge of the atmosphere breathing propulsion technique.
Yeah.
Is that proven in the labs? Do we have any working engines?
Yeah.
Would you mind elaborate a little more?
Yeah. Let me say that a couple of years ago I had to go see it to believe it. So there's papers written about this and others, so you can see it. The issue isn't air breathing engines. I mean, engines once they get a propellant or xenon or krypton or whatever air, it operates the same. The issue is collecting it efficiently. Collecting those molecules efficiently. So there's different designs for inlets, front end inlets that are being researched to see if you can efficiently collect it. Efficiently meaning that the drag doesn't overcome your thrust, that the molecules don't bounce off rather than getting ingested. So that's the research that's quite interesting. And yeah, in chambers, in vacuum chambers on Earth with a plasma source, there's research that is demonstrating the inlet technology.
Where did you see?
Where?
You said you saw it and you believed it.
Yeah.
Where did you see?
There's I'm not. Um, let me get. I'm happy to tell you if it's public, because I think it is very interesting. I think it's not only. But I had to understand the efficiency chain and the math to believe that it's feasible. And yeah, 2 years later, it's it's no longer need to believe. It's time to do engineering on it. But yeah, it's not that hard to create a plasma field. I think even universities, I think C Boulder has some of the best plasma physicists that work in this kind of regime. For example. Any other questions? Yeah.
Yeah, it's like the question has to international trade. It's do you ever get involved in what you call offset when there's a contract with a foreign government over maybe $10 million? You're typically required to do some good for that country.
Yeah, it's not specific to space, but yeah, that's
It could be space or it could be any other.
right. And yeah, a lot of times they'll say, hey, we'll give you this contract because we need that capability, but you need to use 10% of that contract in country here, and they'll have a list of suppliers or so forth. And I think that that's fairly typical. Or it's okay, there's no supplier for that, but they want to do something else with the US. So there's offsets. So
Redwire is involved in offset.
I can't. So the answer is yes, but it's more on the European side. We have Belgium and Luxembourg and how they interact with ESA and other countries. But yes. Yeah, that's the way the world works for the large part. I mean, we don't see it very often, but that is, and it's understandable because oftentimes it's taxpayer money that's funding this, right? Just the same way NASA or the U.S. government, right? Your police department probably buys U.S. made cars or U.S. manufactured cars for the same reason. So yeah, but yeah, that is, and that's okay. Let me take a second on that. So. To the question about commercial destinations and commercial microgravity research, there are a lot of companies out there with great ideas and great vision and a lot of great charts and videos. One of the hard things to do though is have a sustained business in the space industry. So understanding the business of your customers' finances, the business of your own operations, how to get that to be sustainable and not depend on, capital raising, not depend on SBIRs, not depending on and on is really, I think, an area that, our industry needs to grow more into. So it's a very astute question with regards to making sure you understand what the benefits are and opportunities are in working international programs. Yeah.
So for the basic project, if you guys are, it seems like you're going to be extruding just like a 3D printer would. You're sintering regolith on the surface. In fact, like, are you adding a layer of that onto the surface or multiple layers? How are you guys with a rolling platform ensuring that those extruded lines are going to meet with each other and produce a hybrid?
Yeah. Yeah. Good question. And a lot of it is research in progress. So everything from how much power is required, what frequency in RF is at that power level. What's the consistency in depth, right? How thin of a layer do you have to make, and how do you bind the layers, so forth? Do you make bricks and then combine the bricks? So all that is research in progress. One good thing is that there's a lot of regolith simulants here on Earth, so we can go into chambers or labs and practice exactly that. So we have the theoretical expectations, and then we have opportunities to actually go in and practice and demonstrate, and then show the resiliency. Meaning we then have enough materials to use in applications like rovers rolling over it or other applications. So that's all research in progress, but good hard questions that we're taking on. Yeah.
What do the satellites that Redwire create do to protect our nation's satellites from foreign entities?
Yeah. You mean from other satellites? So one of the things is just to be a deterrent. If somebody knows that they're being watched, there's a deterrence there, right? If somebody knows that they can't act without having attribution, there's a deterrent there. So I think a big part of what people are doing in space now is just saying that, and it isn't only from space. There's a company here, a startup, 8 years ago or so, started up that was it's called Leo Labs, and they basically have radars around the Earth that view and track objects in space. That basically tells anybody that, hey, you do something in space, you're most likely going to be watched, identified. They know that you're moving and approaching. So that's I guess that's one of the items that's being done in the space situational awareness area. Yeah.
Space junk.
Yeah.
NASA recently released a study, I think it's probably an AIAA study. It sort of concluded that, well, maybe space junk isn't something that's such a part of it. I think they recommended that the best way to approach it was with lasers, which would nudge pieces of satellites into re-entry orbits.
Yeah.
That's going to take a lot of power. And there's also potential for it's an ASAT weapon.
Yeah.
So where does that work stand? Is that a serious possibility for clear?
Yeah. So I don't know that specific application. I do know that lasers are used. High power lasers are used for different purposes, and just about anything you do in space can be considered an ASAT or a nefarious, potentially nefarious. And even going back to rendezvous and proximity operations, formation flying. I mean, all those are things that somebody can take as. But on the topic of orbital debris, I think number one is that, and I think we're doing it. We're expecting people to be able to clean up after themselves, and that's if anybody here wasn't scouting, only read footstep. I mean, there is a certain expectation that if you designed this thing and you built it, you should be able to deorbit it or move it out of the way or whatever. And I think that's number one. I think people are more and more doing that. When I started, back me up here, but when we started, there were separation systems that threw bolts out of all kinds of stuff was happening. And we finally got around to saying, okay, we're going to capture anything that's going to be cut or separated or released. So I think we've progressed quite a ways. Having said that, micrometeorites are a thing, and you will not get a clean vacuum in space. That is how we were made, and we have to accept it. People enjoy shooting stars many nights, that's micrometeorites hitting our Earth. So orbital debris is not just, human-made stuff that we have to worry about. MMODs are a thing that, we have to deal with on the lunar surface. We're going to have to deal with it. James Webb Space Telescope is dealing with it. It is a reality of being in our solar system or universe. Maybe the next universe will be cleaner. Hey.
Speaking about the space junk, do you think space debris and any hazardous particles in geo orbit might potentially be a limiting factor for future space economy?
I think it'll be managed risk. We already build satellites and habitats to survive, probabilistic kind of impacts and so forth. I believe already there are the commercial astronauts that are planning on doing a spacewalk, right, out of the Dragon capsule. The risk of an impact through a spacesuit, is it could be a bad day. So there are people already managing that that potential and that risk. Will it limit the economy, the space economy? I don't think so, and no more than tornadoes or hurricanes or earthquakes risk the economy here on Earth, which are natural events that have to be considered, insured for, and so forth. So that's, I guess, my initial reaction to that. Yeah.
Is there any part of your micro satellites that could, well, actually, is it possible to just from Earth monitor low Earth orbit well enough to know whether countries are complying with their agreements with each other on which satellites are allowed to be where?
Yeah.
Or do you need other systems acting in space for that?
Yeah. It's a good question, and especially, at one point I had, first we had monitors with tops on them. Now there's no top, but anyway, I had a CubeSat on a 3U CubeSat, and then I had a 1QU CubeSat, and then I had a postage stamp size satellite that was literally inside a magnifying box so that you can see it. So to answer your question, it's first, at what size? Is it a centimeter? Is it a 10 centimeters? So forth. So, but I believe that they are now tracking anything down to 10 centimeters from the ground. So I think anyway, I think within low Earth orbit, I think that is the primary way. There are definitely SSA missions that can not only detect that something is there, but then start to characterize it and so forth. So, yeah, the real question is, if you detect something from the ground and it maneuvers, can you identify that that's what you saw in a different orbit the last time you saw it? Those kind of things are some of the challenges. And when there were only like a few hundred objects that was feasible, active objects that was feasible, with thousands of objects, then you have to start, looking at that harder. So it is an interesting problem. And as you get farther away from LEO and GEO and cislunar, it becomes a very hard problem and not feasible from the ground to really do that. Yeah, cislunar space is a big area, so there's it's so big it bothers me a little bit that human intuition can't comprehend it. When you see graphics in space news or on TV and so forth, it's to try to simplify it for our feeble minds to understand where things are and stuff. But yeah, good questions. Anyone else? Yeah.
I've seen in the past Redwire Space was doing some work with robotic assembly in space, and like feel like a habitat or something.
Yeah.
Is that program under wraps? guys still working for kind of like habitat building states?
Yeah, to the earlier question, there are private habitats that are being worked. You know, we announced that we're part of an orbital reef team. Uh, I don't know the specifics of the robotics that you're talking about. We do have robotics program, space robotics program. Actually, our Luxembourg team is developing a robotic arm called a Stark that has potential of working both internal to a habitat to automate and assist astronauts, but also external in the vacuum. So we do have that, but I can't connect the dots right off on assembling habitats with robotics right off. I do believe that space logistics operations, complex operations, is going to accelerate, especially on the lunar surface. I think there's going to be a lot of automated and robotic activity that's going to be required to set up power grids, to maintain power grids, to maintain just moving cargo off of landers, to do expeditionary operations. Humans take a lot of care in feeding, and it's robotic operations. I think it just by its nature, as we expand on the moon, I think it's going to become kind of the norm. Yeah.
We talked about making stuff in microgravity, like organs and crystals. Are there sort of initial thoughts of what you could make out of it?
Yeah, very good question. People talk about the moon and Mars, and the common response is that, well, we have a lot of experience, 20 years of experience in microgravity, but virtually none in 1/6 gravity or the Mars gravity. And there is interest in what's the potential, what's the benefit of doing some of this research in a reduced gravity environment. Right now the focus of our research is the difference between microgravity and any amount of gravity. And again, that goes back to with any gravity, you get a buoyancy effect in air or water or liquids or anything. So, but I think that there are benefits to a reduced gravity that we still haven't explored. And that is going to be one of the things that I'm sure NASA astronauts and others are going to explore on the moon. Good question.
One last question.
Yeah. Take it easy on it.
I just wanted to tell you how much I appreciated your presentation. Excellent presentation, question and answer. Thank you so much.
Oh, absolutely. Thanks for that. I appreciate it. Look, I'm passionate about it. I believe I've lived it 30 years, but I believe this is the best time in the space industry ever. And by that, I mean ever. If you like going to the moon, we're doing that. If you like LEO habitats and space stations, we're doing that. If you are into defending the nation, there's plenty of adversaries. There's a little bit of everything for everybody, suborbital to deep space. So it is one of the best times in the space industry. So thanks for your comments, and I hope that my passion and excitement came out, and that was it. Thank you.
Last question.
Yeah.
What would you think orbital flight or any other type of space tourism be affordable to everyone?
Good question. So when would it be affordable to the regular Joe on the street to do suborbital flight? I do look back at aviation in this regard. In the early days of aviation, it was pretty expensive, and it was posh, right? They would lay out, like, I think they had tablecloths on your dining areas and planes and such. I do believe it'll be longer than people expect, but within 50 years, I think that we'll have the technologies and the spaceports and the operation facilities not only to do suborbital flight, but point-to-point delivery, transport that will compete with airlines. So you can imagine that first class tickets between New York and Tokyo or something like that. People will pay, $10,000, $20,000. And if you could take 100 people in a starship, between Tokyo and New York, 100 people at whatever, $20,000, $50,000, there'll be people that will pay that. So I think it'll come around. I think it'll be kind of at the premium end of things for a while, and then it'll quickly become something where we can maybe enjoy it. So
with so many detection systems in space managed by Redwire, have you guys seen anything that could maybe be an alien?
yeah. Uh, yeah, I think the short answer is no. The longer answer is, define an alien. Yeah, I don't think there's really anything. I posted the human heart tissue that we printed in space. I posted, exobiology, and which is, maybe the first alien is 3D printed heart tissue. Yeah, I'm not a UAP expert or alien expert, but yeah, I don't think we've seen any green men on camera yet. So, but we'll keep looking. All right. Good.
Yeah. Okay, well, help me
All
thank Al Tadros.
Thanks.